Welcome, future scientists. You've just entered the world of 10th class science.
Hello everyone, this is Kavya. Welcome to my classes. In today's session, we'll be learning how metal carbonates and metal hydrogen carbonates reacts with the acid. So if you are new to this channel, please like, share, subscribe and do comments also. Let's start the topic. Yes, so in today's session, we'll be learning how metal carbonates and metal hydrogen carbonates reacts with the acid. So before going to that, let us understand what are metal carbonates and metal hydrogen carbonates. Our first step is that we are understanding metal carbonate. So what is metal carbonate? A metal carbonate is a compound that contains metal, carbon and oxygen. So this particular metal carbonate has three elements in it, that is metal, carbon and oxygen. So these three combine together to form a compound. So let us take one example, that is calcium carbonate is the best example for metal carbonate. Here calcium is a metal, again carbon and oxygen. So once these three elements combine, they form a compound that is a calcium carbonate. So where do you find this calcium carbonate usually? So we can find it in the marbles and all, marble stones. As you can see, as you heard that Taj Mahal. So in that Taj Mahal, so that particular Taj Mahal is built with a marble stones which has calcium carbonate in it. Again, we can see this calcium carbonate in the shells, that is sea shells. So it is also found in the limestone. So these are the best examples where we can get metal carbonate or calcium carbonate. Let's go to next. What is metal hydrogen carbonate or bicarbonate? So what does this metal hydrogen carbonate consist of? So metal hydrogen carbonate also consists of metal, carbon, oxygen. So it also includes hydrogen. So these are the four elements that are there in the metal hydrogen carbonate. So the best example is common baking soda. So we can call it as sodium bicarbonate also. Sodium bicarbonate or common baking soda. Okay, yes, this common baking soda is used in the cooking. Means for making snacks, for making bread and all, we'll be using this baking soda. So this is the best example for metal hydrogen carbonate. I hope you understood this metal carbonate and metal hydrogen carbonate. So what is acid then? As you all know, you have studied in the previous class. Acid is nothing but it tastes sour and it has H plus ions. When it is dipped or when it is added in the aqueous solution, it produces hydrogen ions. Right? See, as you can see here, substances like hydrochloric acid. So where does this hydrochloric acid is found? It is found in our stomach as well as it is found in the laboratory also. So this hydrochloric acid, once we dip in the aqueous solution, so which releases H plus ions, means hydrogen ions. Again, HCl is a strong acid, children. Yes, let's go to next. That is how these metal carbonates and metal hydrogen carbonates react. Let us discuss this with an example or activity, that is, so as you can see here, this is the experimental setup. So what do you observe in this? We have got a beaker. So this is a beaker which has metal hydrogen carbonate, that is baking soda. So it has baking soda in it. Again, this particular glass has vinegar or acetic acid. So it has acid and it has base. So what we are going to do with these acid and base? Let's see. So we are taking an acetic acid or a vinegar in the conical flask. Again, what we are doing? We are taking some amount of baking soda, that is base, inside the balloon. Again, we are inverting that balloon to the mouth of this conical flask. So then what happens? The baking soda that is present in this balloon will fall into the acetic acid. Then what happens when it falls into the acetic acid? When the base and acid reacts, so the reaction will be taking place, right? When the base and acid reacts, what happens? They produces salt as well as water. Again, as you can see here, that is, this balloon is inflating, means it is becoming bigger. So why it is happening? Because the carbon dioxide gas is being released. The carbon dioxide gas is being released. So as you can see, once this metal hydrogen carbonate, that is baking soda, is added to this acetic acid or any other acid, so what happens? It creates products. Those are salt, water, and carbon dioxide. So carbon dioxide is seen in this. The balloon is inflating, right? Yes. So for example, NaHCO3 and HCl. So this is a base, baking soda, and this is the acid. Once they react together, they will form a salt and water as well as carbon dioxide. So once a metal hydrogen carbonate reacts with the acid, what happens? They produces the products are salt, water, and carbon dioxide, children. Yes. Let's see next. Okay, what happens when metal carbonate reacts with acid? Same process. When a metal carbonate reacts with the acid, so they also form salt, water, as well as carbon dioxide. Let's see one example, that is CaCO3, it is calcium carbonate. When it is reacted with the acid, that is HCl, it forms calcium chloride, water, as well as carbon dioxide gas. So that gas is being released. So I hope you understood that when metal carbonates and metal hydrogen carbonates reacts with the acid, what happens? So they produce salt, water, as well as carbon dioxide. Yes, let's see real life connections. What happens? Okay, some of you'll be telling acidity is more. So acidity is there in my stomach. So what to do? So in such cases, antacids will help you to reduce the acidity, to neutralize the acidity. Yes, that is what here. Baking soda neutralizes stomach acid. Same reaction means, yes, once the acidity is more in our stomach, what happens? This baking soda neutralizes that acidity. So these are all called as antacids, means which reduces the acidity of the stomach. So this is how we are using these chemical reactions in our real life also. Yes, children. Let us go to next. Yes, that is our next concept is neutralization. So let's start this with a song, that is neutralization song. What is neutralization song? Let's start it. Acid and base, when they meet, form some salt and water neat. They calm down and stop the fight, making pH levels right. Now we know what they do, neutralizing. Yes, it's true. So what this poem indicates, so what it is telling, that is when acid and base, when they meet, means when they react. So what they form? They form some salt. So what they are forming? They form some salt and water. So once the acid and base reacts, what they form? They will form salt as well as water. So they calm down and stop the fight, making pH levels right. So acid will be having more pH, base will be having more or less pH. Okay, right? So they'll be, once they both react together, they will form the pH levels right. Means they are neutralizing. So once the acid and base reacts together, they will neutralize. Yes, means now we know what they do. Neutralizing, yes, it's true. So what they will do? Once acid and base is reacted, they'll form salt and water, and the salt will be neutralized. Salt means the neutralization reaction. This is how the neutralization reaction takes place. As you can see here, A indicates acid and B indicates base. So this C indicates neutralized salt and this indicates the water. You understood, children? Yes. Let me give a brief explanation about this. So quick explanation, that is, we are taking an example here, that is HCl. So what is HCl? Is it acid or a base? HCl is an strong acid. So NaOH. So is it acid or a base? Sodium hydroxide. So this is the base. So what happens? When they both react together, they'll form NaCl, that is a salt, sodium chloride. When they both react, acid and base react, they'll form a sodium chloride, that is a salt, and water. So I hope you are understanding this. So this is called neutralization reactions. So some of the real life examples are, so neutralizing the stomach acid. Again, another one is toothpaste neutralizing mouth acid. Means once we eat the food, so what happens? Daily morning we'll brush our teeth. Why we brush our teeth? So what happens once we eat the food? The bacteria is in our mouth. So what they will do? They will make that food acidic in nature. So what happens? So once the acidity increases, our spoils, our teeth will get decay. Okay, to stop that, to prevent that, we are using toothpaste as a base to neutralize that. So what happens? This will prevent the tooth decay, and this will prevent the damage of the teeth. Okay, yes. Let us see next. Yes, our next concept is when metal oxides like base meets an acid. Metal oxides are actually base. Okay, so once they meet an acid, what happens? So let us start with a story. That is, once upon a time in a land of chemistry lived a hot tempered acid. So how the acid will be? It is hot tempered. Okay, what happens next? Who couldn't stop reacting with everything it met? So what happens? That is hot tempered, it is so angry, so it would react whatever it met with. Okay, yes, that is, one day it met a calm and grounded warrior, that is metal oxide. So by this only you can tell which is acid and which is base. So the calm and grounded warrior, that is metal oxide, this will be the base, and our acid will be, he is angry, means he is a short tempered or hot tempered. So what happens when they meet? What happens? Let us see. Okay, so once an acid and metal oxide meets, what happens? Let us see. How they meet each other. What happens in the scene 1? Acid enters the class angrily, shouting, I burn, I sting, I corrode, I want to react. So how the acid properties are there? Means it will burn when whatever comes in front of it. So that is how it will be there, no? Means the properties of acid. So what that acid will tell? I burn, I sting, I corrode, and I want to react. Who wants to fight? So then enters a calm metal oxide. So calmly it enters and says, yes, I may be a metal's child, but I carry a base within. I am basic in nature. I won't fight you, but I can balance you. So what happens? Once this acid shouts, what happens? This base, that is metal oxide, what it does, it comes and says, so I can balance you, let us not fight, I can balance you. Okay, so let's see what happens. So as it tells, let's react then, let's see what happens. So as it is a short tempered, what it will do? Let's react then, let us see what happens. Yes, so let we will also see what happens next. So once they meet, once they react together, what happens? So for acid, they are giving one example, and for base also they are giving one example. That is, for acid, that is, for base, they are giving copper oxide. For metal oxide, they are giving copper oxide powder and dilute hydrochloric acid as a acid, and this is a base. So what happens? Then these acid and base reacts together, they will form copper chloride and water. Again, salt and water. So what happens? Once acid and base they react together, they'll form salt as well as water, children. Yes, so what happens now? Acid will tell, oh, I feel calm, something is changing. Is what it does? The acid says something is changing. Then this metal oxide answers that, yes, I have neutralized your anger. So this is also a best example for neutralization reaction. Yes, children. Next, non-metallic oxide. As metallic oxides are basic in nature, but non-metallic oxides are acidic in nature. Okay, metallic oxides are basic in nature. Metallic oxides are basic in nature. Non-metallic oxides are acidic in nature. So what happens? These non-metallic oxides, that is acid in that they are in acidic in nature. Once they react with a base, they will also form salt as well as water, children. Yes, for example, CO2 again. So calcium hydroxide. So what happens when these two reacts together? They'll form a salt, that is CaCO3 and H2O. So this you have saw in the previous lesson. That is the example for once that slaked lime is applied to the wall, what happens? It converts to calcium carbonate. So this is a slaked lime and this is a carbon dioxide. So once they meet together, they'll form calcium carbonate, which is a shiny surface. Again, so this is a water. Yes, children, this is enough for today. I hope you understood the class. Thank you.